Hello dear students, how are you? Sure, doing very well. Today inshallah we start our second lesson about stars. So what is a star, guys? You remember that in our first lesson we discussed about the universe and the structure of the universe. We talked about Earth, the planets, the solar system, and all this stuff. Today inshallah we'll talk more about stars. So a star is a large celestial body that is composed of gas and emits light. So you remember that we say that stars are made mostly of which kind of gases? Of hydrogen and helium. Yes, and in addition to these gases they also contain other elements, but in small amounts. So guys, stars are shiny objects, as we know. So stars emit light and vary in brightness, and today inshallah we'll learn how we can measure the brightness of stars. What about the temperatures of stars, guys? The temperatures of stars also vary, and it will result in a different colors. Okay, actually stars range in color from red to blue. The red color indicates that the star is cool, while the blue color indicates that this star is hot. Okay, so as we know guys, sun is a star and it has a yellow color. So from the color of the sun we can know that actually sun is a cool star. So you can imagine that we still have other stars that are much hotter than the sun. So guys, let us study the following photo. We can see that we have here different colors of stars. We have different sizes. We have also different brightness of stars. So guys, for A, what is the color of this star? As you can see, it has blue color, and as we said, blue color indicates that the star is very hot, right? So for B, guys, what is the color of this star? It has like orange or red color, and as we said, the red or the yellow or orange color indicates what? A cooler star. Okay, so this star is much cooler than this one. Okay, so what about C? Is this bright area the one here? Okay, one star or more than one star. We can see here the same area has been magnified. We can see that this area looks like it's one star, but actually it contains multiple stars, as we can see here. Okay, so it's more than one star, and we'll see what do we mean, or what is this area exactly, and how these multiple stars are formed. Okay, so stars have different sizes ranging from 0.001 the size of the sun to 1000 times the size of the sun. So it's either very very small, much smaller than the sun, or much bigger than the sun. Two or more stars may be bound together by gravity, which causes them to orbit each other, as we have seen here, guys, in this photo. So here the stars will orbit each other. Why? Because they are bonded to each other by gravity. Okay, three or more stars that are bound by gravity are called multiple stars or multiple star systems. So here we have multiple stars, and we say that multiple stars will form when more than three stars are bonded to each other by gravity, and they will start orbiting each other. Okay, so let us here talk a little about the sun. The sun is a star, and it's composed mostly of hydrogen and helium as well. It also contains other elements such as oxygen, carbon, neon, and iron. At the center of the sun lies the core, where gases are compressed and heated and temperatures reach 15 million degrees Celsius. So hot. The sun's core is where matter is converted into energy. So most of the energy that will be emitted and reach our planet will be formed in the core of the sun. So how is star brightness measured, guys? Apparent magnitude. Apparent magnitude is the measure of a star's brightness as seen from Earth. So it's the measure of a star's brightness that you will see by your naked eyes. So ancient astronomers, using only their eyes, described star brightness by what? By magnitude. And they called the brightest stars that they could see first magnitude. So first magnitude is for the brightest star that they could see by their naked eyes, and they give the faintest stars they could see the sixth magnitude. Okay, so we have the scale here according to the ancient astronomers, start from first magnitude to the sixth magnitude. Okay, the first magnitude represents the brightest stars, while the sixth magnitude represents the faintest star. So that's for the scale that the ancient astronomers used. But guys, after that, as we know, telescopes has been invented. Okay, so using telescopes, astronomers see many stars that are too dim to see with the unaided eye or the naked eye. Okay, so the new astronomers, they added to the magnitude system. They make a modification for the old magnitude system. So guys, today the brightest stars have a magnitude of about -2. Remember what we said about the old scale. In the old scale, the brightest star has the first magnitude, but according to the new system, the brightest stars have a magnitude of about -2. Okay, what about the faintest stars, guys? The faintest stars, according to the new system, have a magnitude of +30. So +30 for the new system, while as we said, according to the old system, the faintest stars have the sixth magnitude. Okay, so them stars have positive or larger numbers, and bright stars have negative or smaller numbers. So if you want to be more brightest than the brightest star, which have the value equal to -2, you should have a magnitude equal to -3. So guys, another term we should know is the luminosity of the stars. So the brightness of the stars and the luminosity of stars. Guys, when astronomers use the word luminosity, they mean the actual brightness of the star. They measure it on a scale called absolute magnitude. So absolute magnitude will give us the actual brightness of a star, okay, not like the apparent magnitude. So absolute magnitude is a measure of how bright a star would be if the star were located at a standard distance. Absolute magnitude is a measure of what? Of the brightness of a star whose distance from Earth is known. Okay, so guys, now how are the surface temperatures of stars measured? Stars have different colors, and as we say, the differences in the colors of stars are due to differences in their surface temperatures. And actually the same is true of all objects that glow. So if an object's color depends only on temperature, this object is called a black body. So as the temperature of a black body rises, it glows brighter and brighter red. as you can see here. Okay, as it gets hotter, its color changes to orange, yellow, white, and then blue white color. Okay, so the color of any object, especially the objects, the black body, or the objects that their colors depends on temperature, the color will vary according to the temperature of these objects. So when you start to heat this object, the color will start from red, and as you are increasing the temperature, the color will change into orange, then into yellow, then into white, until it reaches the blue color, which indicate that this object reached a very, very high temperature. So guys, stars that have the lowest surface temperature, which is below 3,500 degrees Celsius, are red, while stars that have the highest surface temperatures, like above 25,000 degrees Celsius, are blue. And as we can see here, guys, in this table, we can see the difference in color according to the surface temperature. Blue color of stars, if the temperature is above 25,000 degrees Celsius. Blue white for the stars that have surface temperature equal to 10,000 to 25,000 degrees Celsius. The white color for stars that have surface temperature of 7,500 to 10,000. For example, let us see the orange color and the red color. Red color for stars that have surface temperature of or below 3,500 degrees Celsius. Orange color for stars that have temperature of 3,500 to 5,000 degrees Celsius, and so on. So we can see that the color will range from red to orange to yellow, then yellow white, white, blue white, and blue. So guys, as we said, the blue color indicates that these stars reached the highest temperature. Okay, so guys, so far we have studied about the brightness of the star, the luminosity, and color, and the temperature of the stars. Now let us discuss a little about the sizes of stars. Okay, stars differ greatly in size. Some are about the same size as Earth, others are larger than the size of Earth's orbit around the Sun. Astronomers use the size of the Sun to describe the size of other stars. So very small stars, guys, called what? Called white dwarfs. These white dwarfs have about the same radius as Earth, which is approximately to 0.01 solar radius. Okay, what about, guys, the very large stars? Very large stars called giant stars. Typically, they have size between 10 and 100 times the Sun's radius. So, can you imagine how much these stars are big? Some rare, extremely large stars have size of up to 1,000 solar radius. Okay, they are called super giant. Okay, so we have the dwarf stars, we have the giant stars, and we have the super giant stars, but they are rare. So finally, guys, we have this question: compare the size of or the sizes and temperatures of the red, the blue, and the yellow stars right here. So guys, this question will be as a homework for you, and that's all for today. Thank you, and see you inshallah tomorrow.